For the record, this meeting is now being recorded. It will be posted on YouTube afterward. Everyone who speaks during today's event will be part of the recording. We'll do Q&A at the end of the presentation. If you choose to ask a question, your voice and your image, if you have your camera on when speaking, will be part of the recording. If you do not ask a question, you will not be part of the recording. If you're using the most recent version of the app, which we recommend, you can use the raise hand function to join the Q&A queue. If you are using an older version of the app, which does not have this function, please use the chat to let the organizers know you would like to ask a question, and they will add you to the queue. The organizers will let you know when you are next in the queue, so you can be ready to unmute your microphone and ask a question. If you do not want to be part of the recording, the organizers can convey your question to the speaker. In that case, please type out your question in full and let the organizers know you would like them to present it to the speaker. Again, this is being recorded, so if you don't want to be on the recording, don't turn on your camera, don't turn on your microphone. And now that we've got that out of the way, we can officially begin. Hello, everyone. Welcome to the February meetup for the San Francisco Bay Area PostgreSQL Users Group. My name is Stacy Hazler. I'm your host for today. We are recording. We've discussed that. We would like to thank the United States PostgreSQL Association, also known as PGUS, for sponsoring our meetup and for the affiliation with them. As a disclosure, I'm also the president of PGUS, but these are separate things from PGUS and Running Pug. We do have one corporate sponsor, which is PGX Inc., which manages all the recording, producing, editing, and posting of the video. And we thank PGX for the support. And as a disclosure, I work at PGX. It's this little Venn diagram of 3 overlapping circles. During the meeting, if you have any technical issues, please message the organizers for assistance. If you drop out of the meeting and are unable to rejoin, you can post a message on the event page on Meetup, which we're monitoring during the presentation. All that being said, I am now going to turn things over to Richard Yen, our speaker for today. Richard, you are now the presenter. You should be able to screen share and you're all set.
Great. Thank you very much, Stacy. Thank you for inviting me to give this talk. Really excited to be here. And happy Valentine's Day, as is February 14th. So so welcome to this talk. We're talking about, it's entitled How Riding Elephants Safely, and I think it's, I did it because just trying to get some tips to people who might not be that experienced with Postgres. So basically working with Postgres when your DBA is not around. Just to give a little bit of background about myself, I am a software developer and also a support engineer at EDB, which is one of the companies that provides PostgreSQL services professionally. I've been there since 2015, and currently what I'm working on is I work with Golang and Python to make apps internally, but on a day-to-day basis, we are still using Postgres in the backend. And before that, I was working at a web company doing Perl web development. And during that time, that's how I got into working as a PostgreSQL DBA. And yeah, I've been working with Postgres since 2002, and I've loved it. And that's why I'm here giving this talk. So I guess just to get an idea of what this talk, who this is geared towards, I just wanted to give you all just a quick summary. So maybe you might be a software developer or a QA engineer or a data scientist, not working with a database every day, but occasionally, you're using it, but you don't actually have to do the administration part of it. Maybe somebody else manages that database for you, even in the development side. So maybe you don't actually work with the database at all, except just to put data into it and take data out of it. hopefully, for the people attending this talk, you won't be intimidated by command line interfaces. Maybe you will be willing to log into a Linux terminal or console, and for that matter, maybe a little bit familiar with Linux itself. But if you're not, I think that's okay. It's not too hard to pick up and just kind of get your feet wet with Postgres itself. Maybe your DBA is on vacation, or maybe the person quit, or you've never had a DBA at your organization, and you have to manage this database that's storing all of your data. I know that at a Postgres users group, I assume that maybe a lot of you have experience with Postgres, and a lot of this might be review for you, but I would really encourage you to provide some feedback about the topics that I'm talking about today. I will be giving this talk at a Linux conference in about a month, so it'd be great to improve it and provide a better talk to people there as well. Yeah, so Postgres, there is so much to talk about, and I think within the next 40 minutes to an hour, we can't do justice to it. This is just a short, I think it's a short sampling of what there is to talk about, and we cannot possibly go through all of it. So I kind of boiled it down to the following. I just want to be able to talk about how to log into the database and to start to stop it. Maybe you've inherited this database and now you need to kind of get your bearings straight. So at least being able to get connected to it, to pull data out of it, to start it if it crashed, and to stop it if there's some kind of problem with it. We want to be able to do that at the very least. Having inherited a database myself, when I first got into the DBA role, I wasn't sure, what the problems might be in terms of corruption or accessibility. So I really relied on backups just to be able to move the data around, or to come up with a development environment just for myself to use. So being able to take a backup is hopefully something that we can cover for you as well. Also, to be able to diagnose performance and stability issues regarding the database, that would be very helpful, hopefully, to cover, and maybe a little bit about the logs as well. A couple more. Hopefully, we will be able to talk about identifying any schema changes that would improve your performance, so things like indexing or foreign keys and things like that. And then finally, understanding the PostgreSQL's file directory structure, so that way you know where everything is, what to touch, what not to touch, things like that. Okay, so without further ado, we're gonna go ahead and start with the first item. So to start and stop the database, we do need to have console access. So I know most people use SSH to connect to a Linux box and to start and stop the database there. So if you are not familiar with SSH, please work with somebody within your organization to figure out how to SSH into another machine. If you're using a managed database like RDS or Azure, you can start and stop it from the console, and hopefully that is not too hard to do. So once you've actually logged in and have a terminal to look at the database, I think what you want to do is be able to perform some sanity checks. So you want to know how much disk space is left or is available on your machine, because if Postgres is stopped for some reason, maybe it crashed. One possible reason why it crashed is because it ran out of disk space. So you want to check for disk space before you attempt to start it up again. And if there's not enough, you may need to either expand the partition or try to move the data to some other partition. If the database is down, you may want to check the database logs, and that might give you a clue into why the database shut down or why it crashed to begin with. So we'll talk a little bit more about that coming up in terms of where to find those logs. Okay. To start it up, you can use the systemctl command. You need sudo access to start the database. So sudo systemctl start PostgreSQL. I think in some instances you may need to tack on a version. So you'll want to get a listing of all the services that are available to you and use a corresponding service. Now, if you can't use systemctl or systemctl is not available to you, you can use the actual program to start the database, which is what systemctl uses. This is called pgctl. Now, in order to use pgctl, you're going to need to know this variable called pgdata. And in fact, if by the end of today, if you forget anything, the one thing I want you to, if you forget everything, the one thing I want you to remember is pgdata. Pgdata is the most important variable that you need to know in order to get your way around to the database. pgdata is the place where the data lives. It is where all the files are stored, indexes, users, all that stuff is stored in a directory called pgdata. Usually it is in varlib pgsql, but depending on what flavor of Postgres you use or what distribution of Linux you're using, that may be different from varlib pgsql. Okay, but once you figure that out, you can use pgctl to stop the database by passing it in as a directory argument. If you notice at the bottom here, the M and F are modes of shutdown. F is for fast. So fast shutdown, basically, it will end all the existing sessions. So even if somebody has an open PSQL terminal or an app is using the database, those connections are going to get closed and the database can get shut down. MI stop is the immediate stop, which basically simulates a database crash. So you want to use that very sparingly because when you start it up again, it will start up in recovery mode, does a lot of scans, and it could actually take a lot of time. If you can afford to wait, then just don't pass any arguments in. And that will use the regular shutdown mode, which waits for all the sessions to end before it actually shuts down. Okay. So that's starting us off in the database. We're going to move on quickly to how to connect to the database. So if you have your host name, port, username, and password, you should be able to use PSQL to connect to the database. If you're actually SSH'd into the machine, you may even be able to do without the host name and the port. But I think that really depends on your environment. Now, if you're having trouble connecting with these 4 things, you may want to double check your application config for maybe a different port number or a different username or host name that you think that it is, and that might give you a clue what you should be using. Otherwise, you can check postgresql.conf, and that may tell you some things about what port is listening to or what IP addresses it allows incoming connections to use. Okay. Again, PSQL is the default way that users connect to the database to access data, but some people may not be comfortable with command line interfaces, so they use GUIs. And a couple GUI examples are pgadmin and dbeaver. There's a few others as well, but I won't list them here. So once you've actually used PSQL to connect into the database, you'll be able to see something like this. So you'll see I said PSQL-H and then a database.example.com, which is my host name. I use the user edbadmin and then the database name edbadmin. Sorry, it's not an advertisement for my EDB services at my company, but it's just what I've been using for the past few years. if you do \D, you'll be presented with a list of all the tables and sequences that are in the database. Now, note that the \D, it really depends on your search path. So right now it is only searching for things in public and a few other ones that that are not don't have any tables in there. Now, if you ever need to look at other schemas, you can see by using \dn, it will list the schemas for you. And then by adding those schemas into your search path, when you do \d again, you'll be able to see all the other tables in the other schemas that were not originally part of the search path. So the search path is basically like a namespace. By default, it is a user, which is E2B admin in this case, and then the public namespaces. So these two namespaces are the default for \d to look in, and the tables in my schema won't show up. So if you ever want to search for stuff in my schema, you have to do set search path equals public comma my schema, and then when you do \d, it'll show all those tables again. Okay, so that kind of helps you get oriented with how to find your way around in terms of what tables exist and where those tables are in the database. What is going on? Like what kind of queries are being run? What kind of background activity is happening? We're going to talk about that here. So the pgstat activity view is the place where we can see what's going on in the database at that very instant. Now, if you're using a managed database like RDS or Azure, you will have limited visibility into some of the columns in that view or that table, but you should be able to see most of the information that is relevant to diagnosing what kind of issues are going on. So I'll show you a screenshot of that in a moment, but another way to check what's going on in the database is by looking at the logs. So if you actually have a PSQL prompt open, you can say show log directory, and it'll show you the directory of the log so that you can go actually use your bash shell to go to that directory and look for the logs. Okay, sorry. And then if you're using RDS, there's logs as well, so you can actually use that, and that might be helpful. Now, if you discover that in pgstat activity that there's something that's kind of gone astray, or some kind of things just taking up too much time, if you're a super user like the Postgres user or another user that has been given the super user privilege, you can actually cancel that query by issuing pgcancel backend with the PID of that query or session that's going on. And you can also terminate that backend to basically end that user session by using the pgterminate backend function. So pgstat activity looks something like this. You see there's a database ID, database name, PID, and a bunch of other information. You can see the query that's being run. But if your window is small like this, it kind of is hard to read. So what you can do is actually use the \x command, which turns on the expanded display. And then when you do run the query, you actually get all the columns as rows, and then the data as the second column. So here we can see there's an auto vacuum that's being run, and then there's also my query that was select star from pgstat activity. And all this information is it can be helpful in determining, like, when did this person log in? How long has this query been running? Oh, this query has been running for 3 hours and is consuming a lot of CPU, and maybe we should kill it. So this information is pretty helpful as a person trying to ensure that the database is running smoothly for other users. So yeah, so that's pgstat activity, what's going on in the database at this very moment. In terms of configuration, which is what I'm going to talk about now. So once you have PG data, that variable, you can actually find the PostgreSQL.conf file in that folder. In some Debian or Ubuntu distributions, the PostgreSQL.conf file might be in /etc. So you may need to look around and make sure you can find that PostgreSQL.conf file. This is not to be confused with PostgreSQLauto.conf, which is a automatically generated conf file that that is controlled by the alter system commands. So instead of manually changing the PostgreSQL.conf file, you can actually use a PSQL prompt to issue alter system commands that will at least permanently or persistently change the configuration. So if you, let's say you want to allocate a certain amount of shared buffers or memory for your database, you can change that manually by using Vim or a text editor to change the shared buffers parameter, or you can use psql.conf and say alter system set shared buffers equals something. And so both of these are ways to change the configuration. And if you are wondering, how did this configuration get set, you might want to check one of these two files to see, what happened there. Okay. If you want a listing of all the currently available or the current configuration, you can use show all in your PSQL prompt. This is useful because sometimes people make changes to the PostgreSQL.conf and they forget to restart the database or they forget to reload the conf file. And then so what's actually being used as configuration in the database is not the same as what's in the configuration file. So having show all is the way to see what is the actual, the real way, the real configuration that's being used at that moment. Okay. Now some of these configuration parameters, they can be changed on the fly. So let's say I want to change workmem, and I change workmem, and then immediately that's how it's set on my PSQL prompt. Or you can change it from within the PostgreSQL.conf file. And there's other things like accessibility, depending on what parameter it is. The scope of its activeness is really dependent on what parameter it is. So if you actually do a select name and setting from PG settings where context is in SIG-hub or user, these are the things that you can change without having to restart the database. So for example, if you want to change shared buffers, that won't show up in the output of this query. So if you change shared buffers, you need to actually restart the database, and then that way it reallocates the memory and then allows people to use it. Things like log settings, like the prefix or log connections, that stuff can be altered, and then you do a SIG-hub or reload the conf file, and then it'll be active instantly. Okay, so these are a couple other ways to make the changes to your config. If you ever want to reload the database, reload the configuration, you just select pg reload conf as a super user, and then it reloads all the conf files, and then it's active again. And then that way, the show all will match what's in PostgreSQL.conf just for the non-restart parameters. Okay. If you do it from the OS, from your bash prompt, you can use systemctl reload PostgreSQL, or you can use kill hub and then the PID for the postmaster process. Okay. I mentioned earlier search path. So search path is something very important to be aware of. We've had many customers who have come to us saying, "Hey, I swear I have made this table and I can't find it." And sure enough, when we look in the search path, that that table belongs in a schema or a namespace that is not part of the search path. And once we've added that schema into the search path, then the table starts showing up. So knowing your search path value and knowing what other schemas are out there is very useful for you if you need to work with the database. Workmem is also a very important configuration parameter. This is the memory that it takes to allocate sorting and hashing of your queries. So like, let's say you have two really large tables and you're joining them together so that you can scan it and then return some data to your application. If workmem is not big enough, that join process is going to spill out to disk, and then it will get a lot slower. So boosting workmem, knowing when to boost workmem, knowing how much to boost workmem may improve your database performance quite a bit. But you may need to do it on a per session basis and not in your PostgreSQL.conf, because setting it too high in your PostgreSQL.conf might actually crash your entire server, because it will have this cascading effect of consuming too much memory. Okay. The log parameters are very useful. These control like what gets logged, when things get logged, how much gets logged. I have a whole other talk about this. I would be happy to share it with you sometime. But I think a lot of customers that I've worked with, they have overlooked the importance of these log parameters. PostgreSQL's logging is very, very good. If you actually look through the source code for Postgres, there's so much logging going on, and you can turn it on and off with different levels of logging, and that helps you understand very clearly like what is causing your database to be slow. What might be coming up in the future, like we're running out of transaction ID space. What kind of background activity is going on. So this is very, very important to know and to use as a person, especially as a person getting used to Postgres. Okay, and I want to make sure now that you know that the database logs that I just talked about, like what's happening in the database and stuff like that, it is different from wall logs. And I think some people, they might get a little confused at first. So I'm going to explain to you what wall logs are. Okay, wall logs are for the write ahead log. So this is like the redo log if you use Oracle before. This helps with recovering from a crash and allows you to ensure that you've reached a consistent state. So these files, they live in pgdata/pgwall. Okay, if you actually get into your database and you find that in your pgdata folder, there's also a pgxlog folder, you do need to be very careful, because that is a very, very old version of Postgres. And, I don't know how, whether it's been brought up to date in terms of patches and stuff like that. So you'll want to tread very carefully if you're working with one of the older versions. I think we're currently at version 16, and the latest supported version is 11. And pgxlog became pgwall in, I think, version 9.6 or 10. So just to give you an idea of how old that might be. Okay. Wall logs are basically a journal of the write activity on the database. So any update, delete, or insert, renaming tables, things like that, that all gets recorded in the wall log. Okay, and like I mentioned earlier, it provides a means of disaster recovery. The wall logs are eventually synced and merged with the actual database files, which is in pgdata/base. So the wall logs are not your data files, but they are a kind of like a fail-safe and a performance improvement mechanism so that the database can run smoothly. Now, I think it's needless to say, like, do not delete these files. These are very, very important. So if you ever, actually, in fact, in most cases, you do not want to delete anything in PG data at all. Okay. So just give you an idea what it might look like. So if you have a PG data folder on the left, which is barlib PostgreSQL 15 main, this is a Ubuntu machine. That is where this is where all the database files live. Okay. So in this directory listing, there's all sorts of Postgres related stuff and also the PG wall folder. Now, like I mentioned, in some flavors of Ubuntu Debian, the postgresql.conf file doesn't live in PG data, but it lives in /etc. So you see that here in this case. If you ever CD into the PG wall folder, you'll be presented with a bunch of these numbered files with some hex naming scheme. I won't go into the details about that, but you'll see that each one of these is the same size, 16 megabytes, and then usually an archive status folder depending on your configuration. So just so that you know what it looks like and you know not to touch it or not to delete it, this is the wall for you. Okay. All right. And then I'm going to talk about authentication real quick. So if you look in, there's actually another file that is not in here because it is a Ubuntu Debian machine. It is also going to be in etc. This is the PG HBA file, and this is the file that is HBA stands for host-based access. So this file controls who gets to log into the database. So there's a whole separate thing about roles and passwords and layers of I guess usernames and roles and levels and stuff like that. But this file controls what incoming connections are allowed. Okay, so and then so this is an example of what it will look like. Okay, if you open this up, you'll see that there is a column for type. So these are the connection types. There's a local connection, which is a local socket, or a host, or host SSL, and then a database. So all databases or certain database names get this kind of authentication, and then users, and then also a CIDR mask of addresses that are allowed, and then the authentication method. So so like let's say if we are let's say we're trying to connect as the EDB user to the EDB database. This host on the 1, 2, 3, 4, 5th line, host all, it will match this one, right? So does EDB belong to the EDB database belong to the group of all databases? Yes. Does EDB user belong to the group of all users? Yes. Does the incoming host IP address match 127.0.0.1/32? No, it doesn't. So then it's going to skip on to the next line, right? For the first line that all 4 of these connection, I guess, factors matches, that's the line that's going to get used for the authentication. So let's say I'm connecting from my local machine, right? I'm connecting from host 127.0.0.1. Then I will match EDB user, and the address, and I'm going to use a password. And if my password is correct, then I will be able to connect. Okay, so so this is just the HBA authentication in short, and any changes to this can be just simply reloaded with a kill hub or reload conf, and then users will be able to the user access will be controlled by the new version of that file. Okay. All right. let's see. I'm going to go over vacuuming now, which is another very important topic. When you work with Postgres for the first time, you might be introduced to this concept of vacuuming. And when you look in pgstat activity, you might discover like some auto vacuum launcher, and you might be wondering what that's about. So vacuuming is a mechanism that helps ensure Postgres is running smoothly. What it does is it basically prevents bloat by doing the following thing. So when you insert into the database, you add rows into the database files. But when you update or delete, those rows, they're not actually updated and they're not actually deleted. What actually happens is they're marked as deleted. They're flagged with a transaction ID saying, hey, this is, after this transaction ID, it is invisible, right? So the actual data on disk is still there, and it could potentially, when you keep inserting, updating, and deleting, you're just going to get more and more data, and some of it's going to be invisible, and you're going to end up with a bloated database. What Vacuum does is flags those deleted rows, or those marked as deleted. It flags it saying, hey, well, you can reuse this now. It is safe to reuse this row. So, like, let's say the next insert comes, it will say, oh, this one has been vacuumed, so I'm going to insert into here, rather than keep appending to the file. So you can see that by using this mechanism, you can actually keep the file size on disk smaller than it would be if you just keep inserting and updating and deleting. Okay. Now there's a thing called auto vacuum. So Postgres will occasionally automatically vacuum tables based on a particular configuration, and that will go through all your tables and within your database and make sure that things are flagged as reusable at a certain time. And that will actually you don't have to manually do all this work of vacuuming hundreds of tables. It'll just do it all for you, and that'll make sure that the bloating doesn't happen too much. Now, let's say your database is running slowly, and you log in. You see that auto vacuum's running, and you're not sure what to do. The DBA is not around. Usually, it's best to wait for any vacuuming to finish, but if you really have to, you can go ahead and terminate that backend. What that will do is it will basically stop the vacuuming activity for that particular PID or that particular table. However, within a minute or two, that vacuum will start back up again, right? So you may end up having to keep killing process IDs, and that may not be the best long-term solution in terms of trying to recover your performance. So you may have to either wait for it to finish or adjust some of the vacuuming parameters within PostgreSQL.com, and manually vacuum it right away before the auto vacuum kicks in with a different vacuuming configuration. So in order to do that, what I would do is I would first set the vacuum cost delay to 0, and then I would kill the long running vacuum, the auto vacuum, and then vacuum immediately on that table. This is because the default auto vacuum cost delay is pretty high, and it can actually stall the vacuuming process, and also in effect interfere with other queries. So when our customers run into this problem, what we'll do is we'll actually set the vacuum cost delay, the manual vacuum cost delay, to 0, and then terminate the auto vacuum, and then run the vacuum by ourselves manually. There's other ways to do this, but I won't get into that here in this talk. Okay. Okay, I'm going to talk about backups real quick. So hopefully hopefully you're all tracking with this. I'm sorry to throw a lot of information at you, but one of the most important parts of database administration or working with Postgres is backups. So the standard way to pull a backup out of the database is using a program called pgdump. And what this will do is this will dump your entire database in plain text into a file. You can pass in some flags to filter out certain namespaces or tables and things like that. There's also a compressed binary version of it that you can use a flag to toggle. And the nice thing about pgdump is that it is less likely to copy corruption. So what you end up with is a SQL text file or a compressed version of a SQL text file, and that is all your data basically on paper. And now I want to make a caveat, because when I say less likely to copy corruption, it's because there's three types of corruption. First, there's a corruption on the disk, like when the database writes to the disk, something happened to the disk and the data got messed up. The second type is a corruption that is caused by a PostgreSQL bug. So maybe something with the indexing or some particular scenario caused the data to get recorded improperly. And third, there's corruption that's caused by a stray command. So like, let's say I update my entire table with a person's name without a where clause, right? So then all that data gets corrupted because everyone now has the same name, and that's not correct. So when you use a pgdump, you are able to avoid the first two types of corruption. You can make sure that there's no corruption on disk, or any disk corruption is ruled out, and any corruption caused by a PostgreSQL bug might be ruled out. But any corruption caused by a stray DML content is not prevented by taking a pgdump. So that's why I would say less likely to copy corruption. The other option is to take a pg-base backup. Now, pg-base backup is really nice because it's fast. What it basically does is it takes a snapshot of the entire PG data directory, including the indexes, foreign key constraints, and things like that. And it just packages it nicely into a particular folder for you. It basically takes only as long as it takes to copy files from a file system. This is definitely a lot faster than pgdump, because in pgdump it needs to pull the data off the disk and then it gets translated into text and then put into a text file for you. Now, the thing about pg-base backup is that if it's not already configured, you're going to need super user access to create a particular user with a replication privilege, and then you need to configure it in your PostgreSQL.conf with Maxwell senders. And then on top of that, there is the possibility of copying corruption. So if the data is being stored on disk that's already corrupt, or a PostgreSQL bug might have corrupted the data for you. When you do a pg-base backup, that corruption gets copied as well. So it's actually best to have one of each. So you can have pg-base backups to move quickly, but also have a pgdump on hand just in case you need to recover from some kind of corruption. Okay. All right. I want to talk about monitoring. So the logging, I mentioned earlier about how powerful PostgreSQL's logs are. And I'm going to go into it a little bit here, but I'm happy to give a talk on it if you guys want to hear more about it. But the two primary parameters that we use as DBAs to figure out what's going on in the database are logline prefix and log min duration statement. Now, logline prefix basically prefixes every line in the log with a particular set of information, and then it's followed by whatever message that PostgreSQL wanted to tell you. By default, it's very is very short and you don't get a lot of information. And what I recommend to my customers and people that I work with is to set log line prefix to this particular one on the screen here. It basically tells the timestamp, process ID, I forget what L is off the top of my head, a transaction ID, and then the user, database, application name, and then a host name or IP address of the thing that caused that line to get printed. So, like, suppose you have like a bad password, right? That password, it says, oh, incorrect password, attempted to connect a database. Once that attempt is made, this line will get printed, and you'll see what time it happened, which person, what user attempted to log in, and then what database it attempted to log into, and then the host name from where that request came from. So if you ever need to do an audit on, who's some security audits, this log line prefix will help you identify where those potentially bad actor requests came from. The second one is log min duration statement. So as DBAs, we are interested in the performance of our queries, and some queries, they take longer than others, and the log min duration statement will help with that. So when you set log min duration statement, you set it in terms of a number of milliseconds. So like, let's say I want all the queries that took more than 5 seconds to run to be printed. So if I set log min duration statement to 5,000 milliseconds or 5 seconds, if a query takes more than 5 seconds to run, then that entire query gets printed into the log. So then I can tell which queries are slow, which queries are maybe even backing up other queries. So that log min duration statement is a very useful parameter to have. Some other ones that are useful are log statement. Now, a log statement will log every statement that is issued, every query that is issued before it is run. So it may not be very useful if you're trying to find what queries are behaving performing slowly. But log statement, it could help you figure out things like what query caused a crash, right? So like, I don't know what query was running when it crashed, but this one was recorded just before it crashed, so maybe this was the one that caused it. Log min error statement also gives some specific levels of messages in terms of this query, like it caused a particular error to happen or an error, a warning. Log duration, it's useful, but only in a limited way. It just prints out the duration of a query, but it doesn't print out the query itself. It just tells you a query somewhere ran and took this much time. Now, I can see how that might be useful in terms of doing aggregate statistics. So if you want to just say, hey, my database or my app, it takes on average, these queries take on average this amount of time, then log duration might be what you're looking for without actually even having to know the query itself. Okay, but if you're doing that, I would actually recommend using the extension called pgstat statements. That might be more of what you're looking for. Okay, a couple more topics. So performance. So I have a talk on this. It's called explain. So there's basically when we actually try to check to see what a query is doing, we use this thing called explain and explain analyze. And this tool, or this I guess it's actually a query command. So instead of saying select star from table, you say explain select star from table, and it'll actually help you understand what does that query do, so that it can actually give you the data back. Okay. For those who are using ORMs, um, auto-explain can do this for you and store the information in the log, so that might be useful, especially because the ORM does a lot of stuff that you might not know right off or just by looking at it. Okay, so just to give you an example of explain and explain analyze. So here's a query that I have on PGBench accounts, which is like a pre-generated table for a benchmarking app. So explain select star from PGBench accounts, join with PGBench branches, and join condition where AID is less than 100,000. Right. So the query plan that comes out is that it's going to take both of these tables, it'll scan both of them all the way through, and then it'll join them together where AID A.BID is equal to B.BID. And then that join is going to happen by doing a nested loop. I won't go into the reason why it chooses a nested loop, but just to know that there's 99,999 rows in A and only one row in B, the nested loop is going to run pretty fast, right? Now, that's a good plan. I think that's fine, right? But it shows you nothing in terms of how long it actually took. This is just a query plan, and it chooses this plan based on some parameters and some math that it does with the configuration and calculates the cost. So this is the lowest cost plan to run this particular query. Now, as a DBA, we actually want to know what how long something actually took. So in that situation, you use explain analyze. So you just say explain analyze, select star from PGBench accounts and so on. You get this. You'll get actual time that it took for each leg of the query, and then you get actual rows that were retrieved, and then it gives you the planning time, and then it gives you the execution time. So this is all very useful in terms of figuring out the performance of a particular query. And the actual rows is actually very important because the rows that were generated by the explain are actual estimates. They're estimates that are taken beforehand to kind of give you some idea of how big is this table and what kind of query plan we should generate. But the actual rows might be a little bit different because the actual data might have changed since the last time it was analyzed. Okay. So let's say this is pretty typical to do a join, and the performance is pretty good. I mean, it's 61 milliseconds, not too bad. But in some cases, you might need to do some things to the database to help it run a little bit better. And I think the things to be mindful about when you want to improve performance, you want to double check the data types for each of your tables. So you want to be sure you're using the right data types. Some people I've seen have used alt text, which, I mean, it might work for their purposes if there's a small app, but at a larger scale, you want to be able to leverage all that PostgreSQL has to offer in terms of scan improvements, indexing, and things like that. And being a developer, especially in this modern era, we use JSON a lot. And for some people, they might not be aware that PostgreSQL has a JSON type and a JSON-B type. So if you're using JSON, I highly encourage you to use JSON-B, which is a binary representation of JSON. And that allows a lot more flexibility in terms of parsing the JSON, joining using JSON columns, and even indexing. Whereas the JSON data type, it's just actually just simply a text representation of the JSON itself. So JSON-B, if you can't, use that. Okay. Indexing. Indexing is very important in terms of making sure your database runs smoothly. It prevents you from having to scan an entire table if you can afford not to. So I'll give you a quick example about how that works. So let's say I have I did a big update on my PG Bench accounts table. Now you'll see that when I select from it, you'll see that it runs a sequential scan on PG Bench accounts, and then the estimate was 199,939, but the actual number of rows here where BID equals 1 is actually just 1, and it took 45 milliseconds to do it. Now sequential scan, it scans the entire table from beginning to end, looking for BID equals 1, right? And that means let's say it's 1 gigabyte of information. You have to scan through all of that. Whereas if you created an index on BID, it creates another little file, and that file contains all the values of BID, which is the stuff in the parentheses here, and it gives you the addresses of where in the actual table those matches are. So then if you do an index scan, and an index usually on the order of bytes and kilobytes in this particular situation. So when you scan really quickly. You scan all the BIDs, get all the addresses where the match, the BID equals 1, and then you go to the table and just immediately grab the rows that you actually want. And as you can see, the index scan now only takes less than a millisecond, which is a significant improvement from what it was before. So you may or may not be a DBA, but at least being a developer or data scientist, somebody who works with data, you're going to want to make sure your users or your coworkers are able to access the data quickly, and having indexes in mind will definitely help you with that. Okay, a couple more slides. So I've talked a lot about backups and performance, vacuuming, things like how to make sure the database runs well. There are some things that you should not do when you're working with Postgres, and I'm going to quickly go over that with you here. So for some people who work with Linux, you might be familiar with PS, with the process tree and process IDs and killing processes and stuff like that. Some people they like to kill 9 on a process to just kind of quickly force quit something. And in some cases, or most cases, that might be okay. But when it comes to Postgres, you do not want to kill 9 on any Postgres related process, even on a PSQL session. Well, I mean, PSQL session is remote, but on the actual server itself, you don't want to kill 9 on any of the Postgres processes, because what that does, it has a cascading effect and causes not just to that process to be killed, but the entire database server to restart. It simulates a crash, and then it will. When you recover, or when you start up again, you actually have to start up in recovery mode, do a lot of consistency checks and stuff like that. So kill 9 is actually not something you want to do on any Postgres process. Okay, another big thing is idle transactions. So what not to do as an application developer is to forget to disconnect from the database. So people tend to open up connections, run queries, and then they just leave them hanging. You want to close the connections, you want to end your transactions so that other resources are able to use your database. Now, let's say you do have an open transaction. Any locks that you have taken by doing an update or delete, that could block other sessions from using that data, or it may cause other sessions to see a different version of the data that is in the database. So you do want to make sure you commit or roll back every transaction, cleanly disconnect, so that other users are able to use the database. Now, let's say you do suspect something is going on, and you, as a substitute DBA, are looking at the database. You can look in pgstat activity for anything that says idle in transaction. So these sessions are the ones that are in the middle of a transaction that's not committed, and I've seen some situations where these transactions, they stay open for days, and then that's why it's causing applications to crash, websites to be very slow and stuff like that. You want to look for those idle transactions, and hopefully you can use like IP addresses in the logs that you find to figure out where that transaction is coming from, kill that app, which will disconnect the database and free up resources. Or at the very last resort, you may have to do PG terminate backend on that particular transaction that's idle. You may also want to cross-reference with a view called PG locks, so that way you can see what's the scope of impact this idle transaction has. Okay. And again, if you're not the DBA or you're filling in, I would suggest that you don't drop anything. Don't drop columns. Don't drop schemas. Don't drop indexes. Rather, rename them. Rename them and come back later after you get some another set of eyes to help you figure out, do we actually need this table? Do we actually need this index? Things like that. And then if you rename it and something happens to your application, then you can just rename it back, and then things will be fine again. Okay. Again, do not delete any files or folders from PG data, especially things in PGWall and PGXlog. Okay. All right, so that's kind of a wrap up of that's kind of pretty much all I have to cover for today. If you need further help, you can use any of these resources. There's a Postgres community Slack. There is a Postgres community mailing list if you prefer email. There's actually an old school IRC chat that people use and are pretty active on. There's wiki documentation. The documentation for Postgres is really, really good. So if you ever find yourselves wondering, what is this? What is replication? What is a vacuum? The documentation does a really good job of explaining all that to you. And as always, EDB support is there to help you if you're interested in professional level support. And all these links are actually collected in a link tree that I created called linktree/Postgres_help. Okay, so I hope that you guys found this talk very useful, and totally open to any questions or suggestions for improvement here. And thank you very much.
Great. Thank you, Richard. So let's go over questions. You can either raise your hand or drop a note in the chat if you have a question, and Richard will be happy to answer. Okay, there aren't any questions in the chat. Oh, what a nice slide, Richard. Thank you. That's wonderful. And happy Valentine's Day. Because we love Postgres. We love our blue elephant. So let's see. So I'm not seeing any raised hands. Are there any questions? People good? Oh, wait. We have over in the chat. A great overview talk. It is so important to reach out to users that are not yet in the PostgreSQL community at events where these are gathering. Good luck with your talk at the Linux conference.
Thank you.
Yeah. So this was a great talk. Thanks, Richard. And a second one. This was a great talk. Thanks, Richard. So, yay.
Thank you.
Are there any questions or comments for discussion? It was really comprehensive. And I have to say that as not being a Postgres engineer myself, I was still able to follow your talk and understand everything in it. So
Okay.
that points for clarity on that one. I certainly wouldn't turn myself loose on somebody's production database. That might not produce the desired results, but I was able to follow it, and that's I appreciate that. So I was like, okay, that was really clear and straightforward. So that was great. Okay, well, we don't have any questions, so I think we're good. Thank you so much, Richard. That was a terrific talk. And,
all right.
Yeah, and thank you to everybody who attended. It was really great. And hey, no, stop. And it's trying to do things. Don't do things. Why are you doing this? Oh, go to meeting. You're being silly. So let's, so yeah, so thank you so much, Richard, and thank you for everybody for coming. Thank you again to PGUS for sponsoring our meetup and making it possible for us to do these kinds of events and to share the Postgres knowledge and the Postgres love. Thank you to PGX for the video support and processing. Coming up for PUG, we're not doing an event in March because PG Day, Nordic PG Day is March 12th and PG Day Paris is March 14. That's the week we'd usually be doing SF PUG. So we're not doing March. We on April 10, we have How to Avoid Angering the Postgres Elder Gods with Keith Fiske, which is a great talk title. On May 8th, we have What's the Opposite of a Corn Dog? Using Postgres and AI to Find Out with Karen Jex. That was going to be our January talk. And Europe had a breathtakingly huge snowstorm. And Karen ended up getting cut off with no connectivity, which made it impossible for her to present. So we rescheduled for May the 8th, and hopefully there will not be any snowstorms in Europe that week. So that's our next two PUGs. We are looking for speakers for June and onward. So if you're interested, please drop us a note. We'd love to hear your talk, love to hear ideas, share your knowledge with the community. Other events coming up, I already mentioned Nordic in Oslo on March 12th, Paris March 14. Closer to home, PG Day Chicago is April 26th. That is a PGUS event, and I hope to see you there. And then there's pgconf.dev in Vancouver, being presented by the new nonprofit in Canada, Sonic Events Canada. That's May 28 to 31. Looking forward to that. And then just announced PostgresConf Europe. Yay! It's going to be December 12 to 15 in Athens. So buy your truck, or not December, not, oh my God, where did I get December? I'm so sorry if that's wrong. That is last year's dates. Let's see, it's, Europe. You know, everything starts with Postgres when you try to go look it up. Let's see. Oh, and I missed PGConf DE, which is April 12 in Munich. How did I miss that? But it's in Athens in October for PGConf EU. So very excited, looking forward to that. So those are upcoming events you can plan for. Some of them will be recorded, so you can watch them later if you can't go. Some of them won't be. I'm not sure which ones are which, but stay tuned. Anyway, so lots of interesting things coming up. Again, if you're interested in speaking at SF Bay Pug, please drop us a note. We would love to have you. The video will be edited and posted to YouTube. So watch our social media. We'll also announce it through the Meetup mailing list and also post it on the Meetup event page. Thank you again, Richard. And we'll see you all either at one of the in-person events in March, or we'll see you for the next PUG here on April 10. Thanks so much, everybody. Have a lovely, lovely afternoon. Bye-bye.
All right. Have a good day. Thank you.
Thanks.